Okay, so now I'm gonna start the cool stuff. You might think that the ribbon setup is some crazy, heavy and complex rig, but it's actually really simple, and the cool thing is that it evaluates really fast. So the secret to the rig is just stupidly simple, really. I'm actually using Maya's nonlinear deformers to extract their behavior, which means that you will get the same flexibility as you have with deformers. So you can take advantage of all of their options without having to create any extra utility nodes. So you get a lot of flexibility for free. I've switched from Maya 2012 to 2015 as we have to do a couple of connections. This setup works fine in older versions of Maya 2. The only difference is that the hair menu is placed in the dynamics menu in the older versions, while in 2014 and 15 they're placed under the end dynamics menu. So I'll just start by creating a NURBS plane. I'll give this 10 in width and 10 in the U direction, which means that I'm going to create a ribbon consisting of 10 joints. I'll call this ribbon geo. And I'm gonna delete the history and just make it a bit easier to see. So as mentioned, I will need to extract the behavior of the deformers. So I'm gonna create some rivets, which I will use to drive our ribbon joints, or the skin joints, if you will. I'm gonna use the hair follicles to do that. So select the NURBS plane, go into the end dynamics menu, and hair, and create hair option box. I'm gonna output NURBS curves. I want 10 follicles along the U direction and 1 in the V direction. I'm just gonna set this one to static as we're not gonna use the hair system dynamics. I don't need the hair curves or the nucleus or hair system, so I'll just delete them. And if we look under each follicle, there's an empty transform node that we don't need. So I'll delete those also. I'm gonna call this one ribbon follicle grip. So I'll need a joint under each follicle, and I also want each joint to have a separate controller so that I can adjust each joint individually, and I'm also gonna have a group on top of that. I could do this manually, but I'm just gonna do this with a script to save some time. So this script will take the selected rivets, loop through them, and for each rivet, it will rename it, create a controller, create a joint under the controller, and group the controller, set a color, parent the group to the follicle, and snap the position to match the follicle. So when I run this, you can see that each follicle has gotten a hierarchy below it, consisting of a group, a controller, and a joint. And when I move the surface, you can see that everything sticks to the surface. The same applies if I deform the surface. So just to demonstrate, I'm just gonna create a deformer and test it. So as you can see, all of the controllers inherits both position and orientation. And you can take each controller and offset it if you want. This will be our final ribbon surface, but I don't want any deformers applied directly onto this surface, so I'll just delete the sign deformer. I'm actually gonna have separate surfaces for each deformer and then blend shape them into this one in the end. So before we continue, I'll just hide the follicle group. Now I'm gonna create the controllers we need. This will be ribbon middle control. I'll give this a color before we duplicate it. I want one in the start. This will be ribbon start control. And one in the end, ribbon end control. Just positioning the controllers. I want the transformations of the controllers to be 0, so I'll just duplicate the controllers and delete the shapes. and I'll just add a suffix to them. Now, as I parent each controller to the groups, you can see that the transformations has been zeroed out. So the reason they're 0 is that the parent stores the transformation. So relative to the parent, they're 0. Now I'm going to create some attributes. I'll start with the start and the end controllers. This will be our twist separator. Then I want a twist attribute, which will be a float. And for the middle control, I'll start with a separator for this one also. This will be our roll. Then a roll attribute and a roll offset attribute. The next one is the sign separator. And for the sign, I want amplitude, sign offset, and sign twist. And I'm just gonna lock the separators. I want the middle control to follow 50% between the start and the end controller. So I'm gonna select the start and the end, the group of the middle control, then point constraint. Now that we have our controllers, we can start with the deformers. I'll start by duplicating the ribbon surface and hide the original. This will be our twist deformer. I'm gonna apply a twist deformer to this. Rotate it 90 degrees. I'll call this ribbon twist handle. And the deformer. So the start and the end angle twist from the start or the end. You could also set up a connection to the high bound or the low bound if you wanted an option to adjust where on the surface the twist should happen. I have to connect the controllers to the deformer, so I'll select the deformer and all of the controllers and go into the node editor. I need to combine the roll and the roll offset with the twist of both controllers and pipe them into start angle and the end angle. So I'll start by creating a plus minus average node. I'll call this ribbon twist start sum, as this will be connected to the start angle. I'll just duplicate it, so I'll get one for the end angle also. So I'll start by connecting the twist from the start to the first input. And the roll should, yeah, I have the wrong node. The roll from the middle control should be connected to the second input, and the roll offset to the third input. And I'm just going to do the same with the end. Then connect the output into the end angle and the start angle. Now you can see that you can control the twist from with the start and the end controller, and the roll can be adjusted with the middle controller. I'm gonna group the deformer, ribbon deformer group, and just hide the deformer. I'm gonna make a new duplicate of the surface and hide the twist surface. This will be Sign Blend Geo. I'll just clean the outliner a bit. And put everything we're not gonna transform into ribbon no transform group. I'm gonna create a sign deformer. Rotate it 90 degrees and rename it. Now, to prevent the ends of the surface to go up and down, I'll just set the drop off to 1. I'm going to connect from the middle controller to the deformer. So amplitude to amplitude, sine offset to offset. And the sine twist has to be connected to the transform of the deformer. Into rotate Y. And that's all we need for the sine functionality. I'll just clean up the outliner a bit. The next thing to do is to make it possible to move it around. We need to be able to stretch and compress it and bend the middle part. So I'll start by creating another duplicate of the surface. This will be the wired surface, because I will actually use the wire deformer to create this functionality. The wire deformer basically gives you the option to deform a surface with a NURBS curve, which is perfect because you'll get smooth arcs even if you just have a few points. And they don't have a normal direction, so you can deal with the rotation of the surface separately. So I'll create a 2-degree EP curve. I'll draw 1 point at the end controller and 1 point at the start controller, which gives me a curve with 3 points. And you can see that it gives me a smooth arc even with only 3 points. To control these points, I'll use clusters. I'll start by selecting the middle point and the start point and create a cluster. This will be the start cluster. The cluster is created in the middle. The position doesn't really matter, as we're just going to use the translation of the cluster, but you can set the origin under the shape of the cluster if you want to. Then the cluster will, or the cluster icon will snap to the position you specified. I'm just gonna snap the pivot to the controller. I'll do the same thing on the other side. And this is the end cluster, and one final cluster in the middle. Ribbon middle cluster. I'll just group the clusters and rename the curve. Now I want to connect the controllers to the clusters. The controllers translate into the clusters translate. and check that it works. And then the start controllers translate into the cluster. And the middle one. Now you can see that I get double transformations because I actually have 3 clusters affecting the middle vertex of the curve. So to fix this, I'm gonna set the weight of the start and the end clusters to 0.5 each. So 0.5. So now the point will always average between the start and the end controller. Now hide the clusters. I'll put this group in the node transform group. I'll create a new group for the NURBS curve and put it to the node transform. So the only thing left to do for the wire is to create the actual deformer. So I'll unhide the surface and the curve. Create deformer, wire tool. Now with the surface selected, I'll click enter, and I'll select the curve and click enter again. So if I select the surface, you'll see that the new deformer has been applied. I'll rename this. When I move the controller, you can see that it kind of follows. To fix that bulge on the surface, you can just increase the drop-off distance in the deformer. I'll just set it to 10, like that. Now if I try to adjust the roll, nothing happens, and that's because the twist and the roll functionality is on the other surface, and the same with the sign functionality. So I'll have to combine these surfaces. So I'll select the twist and the sign and the wire surface and create blend shape and set both of the targets to 1. Now you can see that the surface bugs out when I move the controller, and that's because the blend shape is above the wire deformer in the deformation order. To fix this, I'll right click on the surface, go to inputs, all inputs, and I'll drag the blend shape below the wire deformer, and now everything should work fine together. This will be our transform group. And I'll hide the wired surface, unhide the main surface, and follicle group, which contains the controllers and the joints. So the main surface doesn't do anything if I move the controllers, as I just connected the blend shapes to the wire surface, but it would actually be a bit cleaner to pipe all of the surfaces into this surface instead of running them through the wire surface. But it doesn't really matter. I'll just connect the wire surface into the main surface instead. So now you can see that all of the controllers and the joints follow along with the surface. And if I enable the local transform handles on the joints, you'll see that you can actually twist this without getting any flipping. But don't be fooled by this. This won't really help you with avoiding the infamous 180-degree flip in a rig, because even though this allows for unlimited twisting, by directly adjusting the twist attribute, you will hit the flipping problem once you introduce constraints. I've seen some people trying to cheat the flipping problem by just transferring a direct connection from the rotate values, but that would work, but I'm not really a big fan of doing that because the last axis of the rotation won't give you the correct twist. So yeah, but that's another topic I won't go much into now, but maybe later. Anyway, I'll create a surface with some volume and do a test skin just to see how the ribbon behaves. It's actually pretty fun to play with. It will be a lot more fun once you get the procedural volume into place, which is what we're gonna do now. So just delete the skin surface. Oh, and another thing, the transform group can be used to control the entire ribbon. But if I try to scale it, you can see that it won't scale the joints. So I'll just turn off the handles on the joints first. So to fix the scale issues, you just have to do a scale constraint from the transform group to the follicles. So select the transform group and one of the follicles and do a scale constraint. And I have to repeat this for all the follicles. And that's it. Okay, so the volume. This is by far the coolest feature in this ribbon. It's a bit more advanced to set up than the other functionality. Again, I'll start by creating the attributes I want. I'll make them on the middle controller. So separator first. And volume float. Volume multiplier. I'll just lock this one. And a start drop off, which will have a min and a max value at 0 and 1. And end drop off with the same min and max value. And I want a volume scale. And a volume position. So I'll hide the transform group and the follicles. I'll make a duplicate of the surface, which will be the squash geo, and unhide it. Now the way I'll use this surface is a bit different, because if you add a squash deform to this surface, it won't do anything with the rivets if they're placed in the center of the surface. This squash deformer will just affect the width and the length of the surface. Also, it's not the actual position we want from the rivets. We just want to use the position of the follicles and use them as scale values. So I'll start by creating a new set of follicles on the surface. And delete the stuff we don't need. This will be the ribbon squash follicle group. And I'll delete the empty transforms below each follicle. And I'll use the script we used previously to rename them. So just remove everything except the rename functionality and change the rename function to squash follicle. So when I run this, it has renamed all of the follicles. Now I'll apply the squash deformer. Ribbon squash handle and squash deformer. So when I adjust the factor, you can see that when I reach a certain value, it just goes crazy. We want it to be predictable when we adjust the volume control. And that's why I created the volume multiplier, the attribute. So I'll just go from -1 to +1 on the factor, and I'll use the multiplier to increase the factor, or the output of the factor. Also, you'll see that the rivet stays in the middle when I adjust the squash. So we have to get them over to the edge of the surface for them to actually be affected by the squash deformer. So select all of the rivets, and I'm gonna set the V parameter to 0. Now my initial thought when I set this up was to have follicles on each side of the surface, and then measure the distance between each follicle. But that's pretty heavy, and there's a much simpler solution to this. Now if you look at the translate Z, this is the attribute I will use to drive the actual scale of the joints. We don't need to measure anything, we'll just use a direct connection from this attribute. You'll see that all of the rivets have a value of 0.5, and I want them to be 0 when the factor is 0. So I'll set the translate Z of this surface to -0.5 to compensate. So now the rivets translate Z is also at 0. So if I adjust the factor, I have to move the squash deformer to the center of the surface. So -0.5. So I'm gonna make the connections, and hide the controllers. I'm gonna connect from the controller to the deformer. Volume should be connected to the factor, and start drop-off to start smoothness, end drop-off to end smoothness, and close. Now it's actually opposite of what I wanted. It's supposed to be expanded when the volume is set to 1, but I'll just fix that later. I'll set a limit for the volume. Minimum should be -1 and maximum 1. Now I'm going to connect the volume position and scale. So I'll select the controller and go into the connection editor and select the squash handle. So translate X controls the position. So I'll connect the volume position to translate X, and scale Y controls the scaling of the volume. So connect volume scale to scale Y. Yeah, it popped down to 0. It should actually be 5 at default. So I'll just undo and fix that later. For the volume position, I'll have to set a limit for this. So at -5, it's all the way at the end. So edit attribute, volume position, -5, and max to +5. Now for connecting the rivets to the scale of the joints, I'm gonna do this with a script. So it starts off like the first one. It gets the current selection, and for each rivet, create a multiplier and a plus-minus average node. Then connect the volume multiplier attribute to the first input of the multiplier, and the translate Z of the rivet to the second input. Add 1 to the plus-minus average node, because the scale should be at 1 at default. Here I'm just creating a hard-coded prefix, as I need to connect to the group above the current rivet. Then connect the output of the plus-minus average node to scale Y and Z of the group above the current rivet. So I'll run the script. Yeah, I gotta set a value for the multiplier also, because now it's multiplied by 0. So now you can see that the controller scale. It's actually opposite of what it should have been. I want the controllers to scale up when the volume attribute is positive, so a quick fix should be to just flip the squash handle. No. Okay, I'll just reverse the attribute then. So go into the node editor. And I'm gonna grab the squash deformer. And I'm gonna reverse the volume connection between these two nodes. So I'll create a multiple linear. I'll call this squash reverse MDL. And connect the volume to the input 1. And I'm gonna set input 2 to -1 to reverse it. And connect the output to the factor. And now it should be correct. And if I increase the multiplier, I'm just gonna set a min and max for this, because we never really wanted to go below 1. So I'll set the I'm gonna set the maximum to 10 and the minimum to 1. So now everything should work fine. Oh yeah, I forgot to connect the scaling. So I'll graph the scale or the squash handle. And I don't need these. So the default value is 5. So I'll create a plus minus average. I'll call this squash scale sum. And connect the volume scale to input 1D. And I'm gonna set the second input to 5. So I'll just copy the name and open the script editor and set the second input to 5. Now if I connect the output to scale Y of the squash handle and check that it works, which it does. So I'll just clean up the outliner. Unhide the main surface. And I'll create some geometry with volume again to just to check that everything works fine. And select the joints and the surface and smooth bind. Now you can see that everything works together. So the way I use this ribbon is that I parent constrain the transform group to, for example, the arm joints, and then I have twist extractors on each joint that is connected to the roll offset and the twist attributes. And again, you can just use the transform group to move or scale the entire setup. Oh, and this should be in the no transform group. That's pretty much it. All right,